Hi, my name is Robin Sanders, and I'm the instructor for Math 309 Discrete Math 2 this semester. And I want to welcome you to my Math 309 class, and I also want to tell you a little bit about what we're going to be studying and why you might be interested in looking at it as a math major or math education major or a math minor. The topics that we'll be looking at this semester all fall into the broad category of something called combinatorics. And combinatorics at its heart is about the art of elegant counting of very large sets. In other words, one of the kinds of questions that we'll be looking at this semester is figuring out how to count a very large set, figuring out exactly how many elements it has without listing them all. And you saw a little bit of this in Math 270 when you were looking at permutation numbers and combination numbers. That's the very beginning of combinatorics. To give you a basic idea that you couldn't solve using stuff in Math 270, but it's kind of the beginning question that motivates a study of combinatorics, I'd like you to think about this. Suppose you go to Paula's Donuts and you want to order a dozen donuts. How many different ways are there of ordering a dozen donuts from Paula's Donuts? Well, obviously, the answer is going to depend upon how many kinds of donuts they have and how many donuts they have of each type they have. But it's not a simple combination problem or a simple permutation problem. We have to get more clever in order to figure out how to count the number of dozens of donuts that you might be able to order from a place like Paula's Donuts. And in fact, that's really the thing that I enjoy so much about combinatorics, is that combinatorics encourages you to think outside the mathematical box. There aren't algorithms in a meaningful sense for counting, although we'll be looking at certain kinds of counts that will have known answers. But in any general counting problem, what you usually have to do is you have to describe in English how you're deciding to try to count the set. A lot of times there's more than one way of counting a set, and that gives rise to what's called a combinatorial proof. You can get certain identities established by counting a given set two different ways, getting two different answers, but they have to be the same because you counted the same set twice. The other kinds of questions that combinatorics looks at are questions along these lines. There's a certain area of mathematics called combinatorial design. You are creating a type of a mathematical object, and you specify certain properties that you want it to have. And then you have the questions of, does such an object even exist? If one does, how many of them exist? And if one exists, can we actually get our hands on one? In other words, can we construct one? And if we can't actually construct one, can we still prove that one exists even though we can't construct it? So those are the kinds of questions that combinatorics asks. Combinatorics is something that underlies parts of probability, but it's actually a subject that has a rich, interesting history and lots of opportunities for doing research even now. And what I really want to stress is that the problems in combinatorics have a lot of humor or play involved in them. They don't tend to be as dry as some other areas of mathematics are. And so there's a lot of just plain, in some sense, plain silly fun that you can have with the kinds of questions that combinatorists ask. So I hope that this sounds interesting to you, and if you're ready to go on a mathematical adventure, welcome to Math 309, where we're going to do a lot of counting.